Okay, so we're continuing working on the project for the face detection. I don't have a lot of prepared material for today. One thing I did want to show you is loading in the image and converting it to grayscale and resizing it. Why is that font smaller? Weirdest thing. Really weird. Anyway, so I put this file in the same folder where the mcfall.jpg is. I think that's the way I've asked you to submit it, is to include that in the same folder so you don't have to put any backslashes or dots or things to go to other directories. So what I've done here is sort of a mixture of using OpenCV and MATLAB. Many of the operation, I don't know, for some reason I've done more of the operations of manipulating images in OpenCV, even though there is matplotlib.image, which does all similar things as OpenCV. So for whatever reason, I kind of mix the two. I like using matplotlib to plot things because it's more similar syntax to the way MATLAB does it. And I'll show you how we can do this fully in well, not fully, where we can load it in OpenCV. So the first thing here just uses the imread from matplotlib. You give it the file name, it loads it in, puts it in a variable. Then I use OpenCV's convert color. So they have all sorts of different features for converting between different color spaces. And so the way this works is you give it what image you want to convert, and then you give it a code. So there's these codes, I guess color underscore RGB to gray is probably a constant, is my guess, is what it actually is. And so there's all these constants for these codes of conversion. And you use the CV2 to say it's coming from that module. And so what this will do is it'll convert an RGB image to a grayscale image. So you put it in as an RGB image and you get it out as a grayscale image. Okay. Then I'm using OpenCV's resize command, where the first argument is the image that you want to resize, and then the second argument is a tuple of the number of, I'm not sure if that is rows comma columns or columns comma rows, because sometimes they do X as the first thing and then Y as the other. Since it's square, I haven't, it's 19 by 19, I haven't paid attention to which one that is whether it's horizontal is the first thing or vertical is the first thing. It all depends on your perspective. If you're talking row comma column, row is vertical first. If you're talking X versus Y, then columns are first. So I'm not sure about that, but as long as it's square, it doesn't really matter. What I've done here is not taking the entire image, because you're not going to be taking the entire image. You're going to be taking some window size. Here I've just chosen a window that's 70 by 70 pixels. I think that's too big for my McFall picture, but you'll have to play around with that of what works. So I'm starting at pixel 1010 and then going down into the left 70 pixels both across and down. So I'm picking a portion of that image that is 70 by 70 pixels and then resizing it to be 19 by 19. Then I open a figure 1 and plot the full image that's color. Open figure 2, plot the grayscale image. Open figure 3 and plot the resized one. An interesting point with Matplotlib's imshow is that the default color map, and that is what colors get associated with different values, has actual colors in it. Okay, it's like in MATLAB the default one is has yellow as the lowest number and blue as the highest number, and varies the colors in between. It's something like that here. So if you wanted to actually show it as a grayscale image, you have to tell it you want to use the gray color map. And so that's what I've done here. Okay, if it's a RGB image, then you don't need to say whatever color map. It'll use the colors that are in the RGB. Okay, so you run this, and I get 3 figures. There's the original image in its full resolution and full color. Here's the grayscale version of it in its full resolution. And then this is starting at pixel 1010 and then going down into the left 70 pixels, and then it's resized to be 19 pixels by 19 pixels. Okay. You can, if you want, change this to be CV2. CV2 has an IMRead function, and it'll do the same thing. Interestingly enough, however, the picture doesn't look right. Okay, and that's something I've mentioned before, is that when OpenCV loads an image, it loads it as BGR instead of RGB. And at first you're like really mad at OpenCV for doing this, but I looked a little bit into why they've done it. And they've just sort of reversed which is the most significant bit, you can kind of think of it as, is which one is the first thing and which one is the last thing. And that's actually a classic battle in digital logic over whether the most significant bit comes first or whether the least significant bit comes first. And they call it either big endian or little endian. Not Indian. At first I thought it was Indian, but Endian. So that's sort of a classic battle, is whether you put the most significant bit first or the least significant bit first. So that sort of seems to be the battle here playing out between OpenCV and Matplotlib. Okay. Interestingly enough, there is a BGR to gray conversion. But it doesn't matter. The grayscale conversion is going to be the same whether you do BGR or whether let me confirm that. That one, figure 3 uses BGR to gray, and figure 4 here is going to use RGB to gray. And we'll compare figures 3 and 4, and hopefully I don't make a fool of myself. They should be exactly the same. Okay. Figure 3 and 4 are exactly the same, no matter whether I used RGB to gray or BGR to gray, and that's because all three colors they are weighted the same when it makes a grayscale. Really, you just take the average of the R, G, and B values, and that gives you grayscale. So when you're doing the converting, it doesn't really matter whether you do RGB or BGR to gray. You would never notice if you only look at the gray stuff. But of course, you do notice when you look at the color one. Okay? So if you wanted to do this, so that's why if you're going to plot with Matplotlib, it's better to use the Matplotlib IMRead. Okay? If you were forced to do this where you loaded with OpenCV and plotted with Matplotlib, you can easily switch it around. I'm going to import NumPy because I'm going to use a thing called dstack. So I'll just overwrite full here. I'm going to change this back to a 3. That'll bother me. I'm going to overwrite full by using NumPy's dstack. And what dstack is, like vstack, vertical stack, hstack, horizontal stack, dstack is depth stack. So it stacks in the depth direction, the third direction of your NumPy arrays. So what you pass to all these stacking ones, there's also column stack, which, thank you, Tim, you taught me that one. I think you used that, right? I didn't know about column stack. That's really helpful. I've wanted that before. You pass them a tuple of the things you want to stack together. So I send a single argument as a tuple, so I need another parentheses to create a tuple. Okay? And so I need to pass to it the 3 layers. First, I need to pass it the red layer, which is the last one, BGR. So I need to pass it layer 2. And then layer 1, and then layer 0 instead of 0, 1, 2. So how do I get that? I do full, and then I'm going to index all the rows, all the columns, the second depth. Okay, then I have a comma, and I have the first depth, I have a comma, then I have the 0 depth. So this basically just takes full and it rearranges the order of its layers and its depth. Makes the bottom layer the top layer the bottom, the middle layer stays the middle. And when you run this one, then you get the picture to look right. So that's just one weird thing between OpenCV and Matplotlib, that they load them as RGB and BGR. Keep that in mind. But in this project, you're only dealing with black and white stuff anyway. Okay? Oh, you know, maybe I should talk about drawing the drawing the rectangles. There are you could do this either way. You could do this like you did in the previous one. The last project, you used Matplotlib to draw. Once you draw the display the image, then you can draw again over top of it. So for example, we could then do plot, and I could go from 10 to 10 to 70 to 70. That's in the x values. Then I need to come back to the beginning again, and then go 10, 70, 70, 10, 10. I think that will do it. And we'll make it black. Be black lines. Let's see if that works. Oops. There's figure 1, and that is marking in the image the position that we have pulled out. So you can see this image is marked by that space. So if, for example, this gave a detection of being a face, you would draw a rectangle there. And then you'd slide the window over a little bit. If that gave a detection of a face, you draw a rectangle there too. Okay, and that's why so that's how you get to see this, where there's lots of different rectangles of all the places that were detected as faces. Okay. There is another way. Let me see if I can, don't remember this one off the top of my head, but OpenCV Python rectangle drawing functions rectangle. Is there one for drawing a rectangle? Surely there must be. Yeah, rectangle. There. Okay. So this works a little differently. So what you do here with this rectangle is you pass the image that you want to work on, and then you pass a point, which I assume that's in a tuple, and then another point. I think it's the two corners of it. Okay, and what this actually does is it modifies the image itself. Okay, so if we were to do this, pull this guy over so we can see. If we then say, let's do cv2.rectangle, then we'll pass the full image. We'll do this ahead of time. We'll do this. No, we don't want to do it first. We'll pass the full image, and then we need to pass, I'm pretty sure it's a tuple of 0.1 and a tuple of 0.2. And then we need to go from 0.1010 to 0.8080. And again, I'm not sure about the order. I'm pretty sure it's X and Y, not row column. I'm pretty sure that's the way it works in OpenCV, but you can confirm that. And then I guess we'll just go ahead and use the default color and thickness. So now when we do plot.figure4, let me close that just in case. And if we then do plot.imShow full, this should get the rectangle in there. Color is required. Okay, so we have to give it a color. Alright, let's say we'll make it black. It's black 000, it's black 255. I think it's 0, 0, 0. So now you can see figure 4 and figure 1 are the same result, but it's an important difference, okay? That well, I put it in the wrong corners. Oh, this should be 80. 10, 10, 80, 80. They should be 80, 80. So we have figure 1 and we have figure 4. Okay. So this is an important thing to keep in mind with Matplotlib, that it's not like MATLAB. When you do MATLAB, anytime you do a new plot in a figure, it erases the figure. But in Matplotlib, whenever you draw something, it draws over top of whatever is there. Okay, so this is the 7070 one. This is the 8080 one. And if I want to make sure that it is always cleared, I can use the CLF command. So actually, a lot of times, I'll just, every time I open a figure, I'll just go ahead and clear it to make sure there's nothing there. So now you can see it's all by itself. That part went away. And so we got figures 1 and figures 4 that are exactly the same, but there is an important difference, is that in figure 1, it first plotted the image, and then it drew a line in the figure, not in the image. But figure 4 here, it has only plotted the image. The image has been modified. Okay? So full, when I run this command, full actually changes. The pixel values in full change so that there is a black rectangle at that position. Okay? So if you ever wanted to use full with its original image without the rectangle in it, you would have to do that before you ran the CV2 rectangle. Okay, so it works either way. You just have there's some small differences there that can be tricky if you're not paying attention to them. Okay. All right. So that's what I had for sure that I wanted to cover for you to give you a little background. Are there any questions you guys are having about the project so far? It's so boring to put Justin to sleep last night. Anybody have any questions? Nothing specific? Okay. Well, let's work on it, and I'll come around and see if I can help anybody with anything. And